This is a machine, PLC, HMI. There's a pick in place that can take this little puck and move it from here to here. This controls the sequence of operations. It is fed by input from the cylinder, so we know where the cylinder is in space. It's on here and it's up. It's controlled by valves that are air driven, and they control the motions, left to right, up and down, open and closing of the gripper. To do this, we have a ladder logic program that takes the process of these signals and decides what to do next, based on input from the HMI. So right now, we're in manual mode. Go to auto mode, bag, cycle start, we'll start the process, and it will just run back and forth, because that's what we told it to do. You can stop it, start it, stop it anywhere, and resume. There are a fault screen that tells us that something has gone wrong. We're telling the cylinder to be in this position. If it's not, then we should get a fault after a certain amount of time. Pick and place horizontal slide is not at home position, which is here. So that gives the operator, people running the machine, an indication of what's going on with the machine. Fix the problem, start it back up. Alright, this is the software that we use to program. There are push buttons, say what we call normally open contact. The power flows, called ladder logic because it's set up like a ladder. There's rungs on each side, there are rails on each side and rungs in the middle. Through the contacts, you can tell if it's running, if it's green. So right now, nobody's hitting this button. So basically, if the power's not on, then we clear everything out to home. Fault messages. We tell it the power's on and we tell it to go home, and it's not home for 5 seconds, and we trigger an alarm that shows up on the screen. Same deal with the other side of it. If I'm sending it out and that position, home position stays on, then we fault again, because a lot of times switches can go bad, they'll burn up and they'll stay closed. So you got to check both states. Where we check to make sure that it is where it's supposed to be. So it's the left position's on, right position's off, then we know it's at the left position. This is basically the sequence. Every time we step forward, we add a number into this register. And based on what the register is, at the very beginning it's 0. So the first thing we do when somebody hits start is move a 5 into it. So now, if this number is equal to 5, the outputs will fire, and we check to make sure that each thing did exactly what it was supposed to do in that step. If everything's good, then it moves on to the next step. And that's basically it. The sequence itself is the easiest part of programming. The hard part is the faults and fault recovery. If something goes wrong, what do? If you're in the middle of a process and you have a part in the gripper, what do you want to do? You want to drop it? You want the operator to remove it? That's where all the hard work comes in. Writing the actual sequence is the easiest part of the job, because all you're doing when you're writing a sequence, you're assuming everything's going correctly, so if you tell it to go somewhere, it gets there, there's no problems. Hard part's when it does something you don't think it's going to do, and how you recover from that. Outputs, there's manuals on the HMI where they can hit a button and make it go down, hit a button and make it grip. That's useful for debugging. That way you can test all the motions before you get the sequence, because if you start running the sequence and your inputs aren't right, things can go bad quickly. So make sure everything's right. And usually the first thing we do when we put them together is do an I/O check and make sure that the cylinders are wired to the right valves and the switches are in the right location, and everything matches up with the program. We start programming pretty much the same time that they start mechanical design, so we have to work with the designers and make sure that they follow the quote, and if they don't, that they let us know so we can make changes. Because the program is written at the same time assembly starts, generally, and then we're ready to download as soon as they put power on it, and start to shorten up the debug time as quick as possible. And far as programming goes, that's pretty much it. I mean, there's way more than I can get into right now, but at the very heart of it, it's basically taking inputs, processing those, and applying outputs. So based on what you tell it to do, it will manipulate outputs and look at inputs. That's how it makes machines go.
I've been working here at Mertek probably for about 5 or 6 years with a short interruption. I do technical documentation, and most, basically I write the manuals for the machines that they build, and also I create the illustrations, and I do a lot of photography and use a lot of photographs in the documentation to make things clearer. And so I have to, most of the work is done in Microsoft Word, but I also have to be familiar with SolidWorks, because I use SolidWorks a lot for particularly the 3D models for some of the illustrations. Sometimes they're a lot clearer than the photographs because you can get rid of the things you don't want. And but basically what I do is I start with a template and eliminate the things that aren't relevant to the machine and add anything new that has to be added to the machine, and write descriptions of the equipment, maintenance procedures, repair procedures, and that's basically what I do.